I'm just going to start. I'm a little early, but I'll just start. My name is Marc Prioleau. I'm the Executive Director of Overture Maps. Just to kind of level set, how many people kind of know what Overture Maps is or have heard of it or something? Okay, good, because I wasn't really going to tell you what it was. So if you didn't know, if you don't know, you're going to have to infer. I'm on OSM, I'm Mark, and for some reason, you have to spell it with a capital M and a C, because that's the way it was. If you look it up, the most impressive thing is my first edit was in May of 2006. The least impressive thing is the number of edits. I'm not a prolific editor, but I spent most of my life working in technology companies looking at using open data in OSM. So that's kind of where my background is from. And about 2 years ago, I flipped over and became the executive director of this thing called Overture Maps. I'd been involved in help get that started when I was at Facebook before that. And what I wanted to do today is tell you a little bit about Overture Maps, but and something you may not know about it. And one of the things I wanted to frame it in the context is I very frequently get asked the question, especially when I come to these things, about like, why are you doing Overture Maps? We've got OSM, isn't it competitive? And one of the things I maintain, and you can disagree with me if you want, but one of the things I maintain is that if you look below the headline, right, and the headline is you've got these two organizations making open map data, but if you look at what those organizations do, the actual activities, there's actually very little overlap between what OSM does and what Overture does. And that's not a mistake, that's intentional. When we started Overture, the goal was not to in any way compete with OSM, but it was in fact to do some of the things that we felt users needed, developers needed, to be able to easily use that data. So we try very purposefully not to do what OSM is doing. And as I go around today, you know, I look at all the different things that people are doing in OSM, and those are not replicatable anywhere. I mean, that is really unique to this community. The things we do, just in a nutshell, are we use OSM data. I'll talk a little bit more about that. We do combine it with other sources. We conflate those and do quality checks on them, and we put it in a standardized schema, and we attach something which is like a stable identifier I'll talk about. So we can talk more about that if you want. I wanted to tell you something that you might not know about Overture Maps as a way to kind of give you one of the areas where I think it's differentiated. And this is the thing that you may or may not know, but Overture is not about making all map data open. And if I were to look at OSM, and I've looked at it for quite a while, OSM is about making map data open, right? All the presentations are people who are bicycling or doing historical mapping or mapping a trail in Maryland or doing this, and it's building that data and it's making that data open. And that is really, as I see, one of the great missions of OSM. Overture has a little different perspective, and one of the things that we're talking more and more about is if we think about open map data, one way to think about open map data is it's like non-open data, but it's free, or it's got an open license, and that is a way to think about it. But another way to think about it, and what we're thinking about more and more, is how does open data provide kind of a new way of structuring data so that you can start, so the industry can actually accelerate and make mapping easier with a base layer that is open and shared and used by everybody. And that's one of the things. So when we think about the data we're making, our goal is not to make all data open, to build all map data and make it open. We have a very specific set of data we're trying to make open, and then we're trying to make all the rest of the map data, whether it's open or not open, attach to that. So that's what I kind of want to talk about a little bit. So first question is, why don't we focus on all map data being open? And one of the things, I'm just at the end of conference season, and conference season means like the first half of the year, and I go to all these conferences, and the universal theme I'm hearing at mapping conferences is we have this explosion of data. We just have all this data. And the weird thing is, like, everyone says that like it's a bad thing. Like, you know, it should be like, you should be happy, right? But it's not. They're all sad because they don't know how to deal with all this data. Conflation costs are going up. Conflation costs for many of our partners are exceeding licensing costs. And so if you think about it, and you think about mapping, you know, it used to be that, navigation was like, get me from A to B, just like turn me on the right streets, let me know where it is. But now that's not good enough, right? Now we need to know, like, what's the traffic right now on every street, and we want minutely updates, and we want it to predict so that it can reroute us. So in the road segments, the road data has just exploded with all this real-time data. If you look at places, it used to be there's a place, but now it's like, what's the place? And what's the reviews, and what are the pictures, and what are the Instagram things, and do they serve hot dogs, and do they have pets, and can you serve your dog a vegan hot dog, or whatever it is. It's like there's all this data, and the same thing as you go down all the different things, the amount of data is exploding, and the industry, the using industry, the people who are building map applications are really struggling, because when I got into this business, like, you would have your map data supplier, singular. Now you have a dozen or 30 or 50 or 100 map data suppliers. You're collecting data from all over the place and trying to make it make sense. And so what we're talking to people again and again, whether they're in government or whether they're in industry or tech or GIS or wherever, is this problem of conflation is really growing. And so this is kind of the thing we're seeing, is geospatial data is expanding at an explosive rate. And instead of that being like a good thing, it's causing some real problems, because the ability to take that data and sync it all to the right entities on Earth is becoming really, really hard. And so what that ends up doing is doing something we call a conflation tax, which is like this tax everyone in the map-making industry is paying, of just spending a ton of time conflating data. And as I said, one of our members said, big company said, I spend 3 times as much money conflating data as I do licensing data, which is stunning, right? And what happens when that happens, if you're building map data and it's really hard to conflate data, guess what you do? You don't bring in a lot more data, because it's really hard and really expensive. And so the ability to integrate new data and build these apps starts to slow down. So that's kind of the problem that we sort of see. And love to talk to you afterwards, but like, I'm seeing this in every sector of the mapping industry. So one of the things we want to do is just rethink spatial data. And so you've got this explosion, sounds like chaos, sounds really bad. But if you kind of think about spatial data, while there are many types of data, they all kind of ladder down to about 20 basic themes. And the picture there is the UN GGIM 14 themes. I think they miss a few. They don't have things like POIs. But there's not 100 basic themes. There's kind of like 20 of them out there. And if you think about, and so all of a sudden you say, like, this explosion of data, by and large, all of it ladders down to a couple handfuls and maybe both feet of themes. There are not that many of them. And then within each of those themes, there's some sort of basic data. If you think about roads, there's basic data about roads. You can ladder anything you want on it, but the roads are kind of there. And the change in roads is not exponential. It's incremental, right? Roads change. They definitely change, but they change incrementally. Places change, but they change incrementally. Buildings change, but they change incrementally. So now you start saying, well, now, at the base of this explosion, there are a finite, fairly small number of basic themes, and the data that really describes those themes elementally doesn't change that fast. It changes. I'm not minimizing that, but it doesn't explode. Where the growth is, where the explosion is all the data that attaches to those themes, right? So if we use a road example, it's not that the roads have exploded and changed, but the data that we can now attach to the roads has exploded. It's not that the number of places has exploded, it's changed, but it's the amount of data we can attach to that, and so on and so forth. And so if you start thinking about how to solve this problem, you start thinking about it and thinking there's a structure to it. It's not chaos. It's a finite number of themes. Those have basic data structures, and those data structures change fairly incrementally. And so the way we sort of approaching it is, we said we're going to build about 6 of these themes. And so just note, we're building 6. I said there were about 20. There are about like 14 we're not building, right? We're not doing bathymetry. We're not doing land use. So we're not doing everything, but we're doing about 6 of them. I will pause at this moment and just tell you, because I always get the question, how much OSM are you using? And so let me just answer it for you. If you count the number of records, we use just under 40% of our records come from OSM. It's 39 point something. which is kind of interesting. The better question, I think, is which of our data themes use OSM? And that's really the more interesting thing. So I'll just tell you, transportation is mostly OSM. I'm going to say mostly, like 99% plus, but TomTom has added some new roads that are in there. Places is 0% OSM, and I can tell you why, but our places data has no OSM in it. Divisions is mostly OSM, but we bring some other things in, and we're looking at some other authoritative data. Buildings has about 6 different sources. OSM is about 25% of the records, but it is our priority. So if it's in OSM, we flow it down through all the others. Addresses has 0 OSM. We're very grateful to Ian Deese and Open Addresses for getting us started on that. And base is sort of like a context layer that shows a lot of the other stuff, you know, coastlines, things like that, and that is 100% OSM. So if you want the quick answer, it's like 40%, but I think the nuanced answer is more helpful, and that's kind of how we use. So we use a lot of OSM. It's probably our #1 supplier, but it varies by themes. Okay, so here's our thought, is there's a finite number of themes. We're building about 6 of them. What we see is happening with open data is not trying to make all the data that possibly could be in transportation open, but think about what's the fundamental data that is used to describe roads? What's the fundamental data that's used to describe places? What's the fundamental data that's used to describe buildings? And it's a fuzzy line, and our teams argue about where that line should be, but you come to a set of things that basically, without that data, you wouldn't really describe roads. You wouldn't have that. You wouldn't describe places. And our goal is not to make all the data that fits in there open, but to make those, what we call those reference maps, open. And our goal, rather than adding richness to that, and I think OSM does a great job of adding richness, our goal is to make those reference layers very complete, very accurate, and very up to date. And so rather, you know, when we talk about what our goals are to, it's not to keep adding to that, but to make those open and complete, and so that's kind of what our focus is going to be on, is building that out. And so then you have this thing we call a reference map. It's the map that works there. And then the next thing that's really important is you need to be able to provide a stable identifier to all of those entities so that other data can now be really easily joined. Because right now that's a spatial join. The number of people on the planet who know how to do a spatial join is vanishingly small, but the number of people who know how to do column join is pretty easy, or pretty high. And so the framework is the way that you attach data and build the richness in. That data you attach can be open, can be proprietary, can be private, can be whatever, but that's kind of the model we have. So our goal is to make these open data layers that are very complete and accurate, provide stable identifiers in there, and then let those stable identifiers be used by anybody to attach their data to that. And so this is the way it works. The stable identifiers are called the Global Entity Reference System, or GERS, and it's a universal framework for matching the data around it. GERS IDs identify real world entities, so they identify buildings, places, addresses, road segments, things like that. They don't identify like a piece of dirt, right, or like a lat long. And they simplify the integrating of data to really reduce this conflation take. So this is an example where you might have roads, and the roads, we might include the road network, but the road signs, the lane detail, the traffic, the services, all those things could be added. It could be added as open data if the open data exists, or it could be added as proprietary data if that data doesn't exist. The interesting thing about GERS, and GERS is a stable ID system. We did not invent stable ID systems, but we do think we have something unique that has 3 important things. One is it's global. So UK has an ID system, but France doesn't use it, and neither does Spain. And so one thing we think it needs to be global. We think it needs to be open. In other words, it shouldn't be controlled by one company. And we think it needs to be entity-based. In other words, tied to things that people generate data around, like this building, not to a square or a hexagon of dirt. And so we think it's a pretty unique thing, and that's kind of where we're going. I think I'll just show, this is sort of what is Overture Maps. Overture started with 4 companies. Esri joined really quickly after. We're just around 40 right now. Someone made an interesting comment, which is if you go out to the display room, all of the people who are displaying are members of Overture. So if people think that people only support Overture or only support OSM, I would direct you out there. And we're very happy to support this community. It's a big part of our data. And I guess the thing I would say is I think these things really work together well, and hope we can do that in the future. So I think I have a couple minutes, and any questions? Clear? Okay, great. Thank you very much.